Hey, this is Horner. We're going to talk about what you absolutely need to know about electrostatics in order to pass this part of the AP Physics 1 exam. Matter we know is made up of atoms, and there are lots of things in an atom. There's a nucleus, which we see right here, and inside the nucleus we have two things. We have neutrons, which we say are abbreviated with an N and a 0 because they don't have a charge. We have protons, which are a P with a positive. And those, let's call the neutrons here the blue things, the protons could be the red things. And then on the outside, we have moving around electrons, and so we say that they have a negative charge, and you'll see that. The electrons are really important. They are the things that give chemical compounds their ability to stay together. They also help us with lots of chemical reactions. So most of the atoms that we know are zero. They have a net charge of zero. It's because they have the same number of protons as they do electrons. When they don't, we say that these things have a charge. And whenever we look at a charge, we're going to talk about charge in physics, and we're going to represent it with a symbol Q. So if something has a charge, we're going to say that it has a symbol Q. Charge is a really fundamental unit of physics. It's a lot like length and time and mass. And the unit we use for it is called a coulomb. So charge, we use something called a coulomb. So charge is abbreviated Q, and the unit we use is a coulomb, C-O-U-L-O-M-B, and we use the letter C to talk about it. Anytime we look at the charge on a single proton or electron, we're going to use something called an elementary charge, which is E, not to be confused with an electron, but we use this for elementary charge. So this would be elementary charge. And elementary charges are equal to 1.6 times 10 to the negative 19th coulombs. Now, there's a little bit more to that. For this, we know that this value for an electron, so if I have an electron, it's going to be negative 1.6 times 10 to the negative 19th. And for a proton, the charge is going to be equal to 1.6 or positive 1.6 times 10 to the negative 19th coulombs. So be really careful that when you're dealing with electrons, use the negative number, and for protons, use a positive number. Neutrons don't have any charge, so you wouldn't have to worry about those here. Let's go ahead and take a look at our first problem. Our first problem says we have an object that has an excess of 6 times 10 to the 6 electrons, and what charge would it have? So let's start with the number of electrons, which is 6 times 10 to the 6th electrons. So I use the abbreviation E with a negative sign. We know that for every one electron, we have 1.6 times 10 to the negative 19th coulombs. So we said that the elementary charge E, so here's an electron, has a charge of 1.6 times 10 to the negative 19th. But we also said that an electron has a negative charge. At this point, we need to go ahead and do our math, and we end up with negative 9.6 times 10 to the negative 13th coulombs. For number 2, an alpha particle consists of 2 protons and 2 neutrons. What is the charge of an alpha particle? Well, we said earlier that neutrons don't have a charge, so we don't have to worry about those. And protons have a charge of positive 1.6 times 10 to the negative 19th. And remember, we call that an elementary charge, which is abbreviated with an E, not an E negative, that's an electron. So a proton, we can either write it 2 protons, or we can write it 2 elementary charges, either way. And when we do that, we could say that every 1 proton or every 1 elementary charge has a charge of positive 1.6 times 10 to the negative 19th coulombs. Let's go ahead and do our math. If you multiply the two together, you end up with 3.2 times 10 to the negative 19th coulombs. And notice that this is a positive number. So if you want to make it very clear, you can put a positive in front or just leave it positive, one of the two. For the next one, it says if an object has a net negative charge of 4 coulombs. So it has a net negative charge of 4 coulombs, so negative 4 coulombs. The object possesses how many more electrons than protons? So here we know that the charge is negative 4. And we've got to go ahead and convert this over to electrons. So at this point, we're going to say one electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. Notice that I have both a negative on the top and on the bottom, which is good because that gives me the number of electrons. We would not want this to be a negative number. And if you do your math, you end up with 2.5 times 10 to the 19th electrons. So that's a lot of electrons in order to have that charge. For number 4. Number 4 is a multiple choice question, much like what you would probably see on the AP test. It says, which quantity of excess electric charge could be found on an object? Well, we know that excess electric charge has to be in multiples of 1.6 times 10 to the negative 19th coulombs. This would be kind of like a dozen. You can't have well, it's not really like a dozen. It is an absolute value for charge. So we know that this is equal to 1 proton, or if it's negative, it'd be 1 electron. So you can't have a part of this. You couldn't have 1.3 times 10 negative 19th. It wouldn't be enough charge to create either of these. And you can't have a part of a proton or part of an electron. So let's look at the numbers. If we look at the numbers, we'll notice that letter B is actually a multiple of 1.6 times 10 negative 19th. If you take 6.25 times 10 to the negative 19th and you divide it by this number, you're going to come out with a fraction, a fractional number. If you do this number, 4.8 times 10 negative 19th divided by 1.6 times 10 to the negative 19th, you get a whole number, which is 3. So because that one comes out with a whole number, that's our answer. Now we don't have to mess with the other two. For number 5, it says, what is the net electrical charge on a magnesium ion? So they're trying to make this look really difficult, but it really is not. This magnesium ion is formed with a neutral magnesium atom, loses 2 electrons. So if magnesium starts, let's just say that it starts with 26 protons and it starts with 26 electrons. I'm not sure if that's right or not, but let's just say that it does. If it loses 2 electrons, now it has 24 electrons and it still has 26 protons. So if you take the two numbers and we subtract them, 26 minus 24, we end up with a net of plus 2 charges, or 2 extra protons. So now we need to figure out what is the charge there. So we have 2 protons, and we know that each 1 proton has a charge of 1.6 times 10 to the negative 19th. Remember, this is positive because it's a proton. And when you multiply the two together, you end up with 3.2 times 10 to the negative 19th coulombs. And that will be answer D, not answer A, because this one is negative, so it can't be that. These are not a multiple. This is just a single charge. So our answer here has got to be letter D. And that is the end of the first section of the notes for electrostatics.